let's hear about the best practices for Azure Kubernetes Service.
Thanks, Kim. So today I'm going to go over some best practices for Azure Kubernetes and Kubernetes in general, such as deployments, building, networking, private access, and go through all those. So to talk about private access first, you want to enable access to the control plane. The control plane essentially does almost everything in your cluster. It controls pod scaling. It controls deployments, secrets, containers, pulling containers, and deleting containers as well. So it's very pivotal to protect the control plane. And I really don't see any good reason to open it up publicly. It should, under no circumstances, be open to the internet. Because if someone's able to steal your credentials, they're able to have essentially unrestricted access to your Kubernetes cluster. So you must have private endpoints, and you should do this when you enable the cluster. Azure, for whatever reason, allows a public control plane. So just make sure when you first build your cluster to enable it to be private. You can also set up an ingress controller too, to talk further into ingress. And this is to your application. So you can still have, let's say, a public endpoint through your ingress into your Kubernetes pods. Say you're running a website, you need that public access because you need everyone in the world to get to your website. But you have to be sure to protect the control plane. So some people might get confused, as in control plane versus the actual AKS workers and nodes and pods. So they're two separate. You should have two separate endpoints. Completely isolate them.
Gonna mention, so on this control plane, you want to make sure that they're able to have access from a private endpoint for Azure. So that needs to be established before. Some organizations or companies don't have that way to use a private endpoint in Azure from their on-prem or whatsoever. So if it's all internal in Azure, like say endpoint to endpoint and from cloud to cloud, or say not really cloud to cloud, but more so say Azure to Azure, from US East to US West, that can establish a private endpoint. But if you're trying to establish a private endpoint from your on-prem to Azure, that needs to be established way ahead of time with the Microsoft Azure.
Right. That's a very good point, Kim. And especially if you want that express route routing, you do need to pay an ISP to do that for that networking path as well. So say you're a small company or you're just a developer and you want to spin up a quick Kubernetes cluster. What I would recommend is to spin up a jump server in a DMZ, allow that access to that VM, and then you can put your kubeconfig file and credentials on that VM to have that private access to the control plane. So you have at least one layer of defense over that. But you'd have to obviously make sure to protect your DMZ and the machine there. And obviously only allow certain ports. Like if your server there is you just want to SSH to it to be able to get access to Kubernetes, just open port 2022. There's no need to open other ports in that case.
When you do set up Kubernetes, when the cluster is established, it automatically creates a public-facing load balancer, which is that standard load balancer. The ingress controller, where you see in the little circle at the top, when you say, have load balancer internal, to create an internal load balancer, that's where a second Azure load balancer is created. So you'll see in your Azure resources that you'll see a public-facing load balancer, and then you'll see an internal. It'll say Azure internal or load balancer dash internal or something like so. Whereas that is your load balancer that's doing the controlling of the ingress for your internal space. The public facing one also, that one you would have to actually on your network security groups, you must always block anything to that public IP. So whenever it's created, you go to your network security group and set up a policy to say to block all traffic to that public IP, and then you'll just be using the internal one.
That's a good point. I forgot to mention that it does come with a public load balancer with a public IP. Azure does that for websites, since a pretty popular application is building websites on Kubernetes. Right. So yeah, so I guess if we want to have an example, say we have a website, you want to protect that, have that access open to the internet for other users to sign on. But if you do need to get access to other pods to have the databases then you should spin up your own internal load balancer and set up a private access into your databases, because you don't want your databases behind that public load balancer.
Right. And so that public load balancer, another thing is that it creates the rules that are there, plus, or for external access, it has an outbound rule to allow that particular Kubernetes cluster. All of those are allowed through the load balancer and outbound access as well. But we don't use that particular. You should never just, if you're just trying to strictly be internal, just never use that public facing load balancer. But some, like I said, some people do use that public facing one. But you'll just be, offsetting it with that internal one if you just want internal access to your cluster.
Great. And I don't recommend this, but if you're a team that just uses that public load balancer and you're not building a website, have very, very, very strict network security rules.
Yeah, you have to have a firewall in front of it.
So there are a couple different patterns to protect egress communications from Kubernetes to the internet. The pattern I'm going to go over is using an Azure Firewall. So you can use Azure Firewall and update the route tables to route all your traffic from your Kubernetes clusters to the Azure Firewall. And you can do that via the Azure portal or Azure CLI to write those rules. One thing to make sure of is there's a link in the slide here, and it has the required domains to make your cluster work. So you have to be careful, because if you don't add these rules to your Azure Firewall, your cluster won't work as intended, and it won't scale, and it won't update correctly. Now, you can also add additional domains that require outbound access. So if you require access to Docker Hub, you can put a rule in that says star.docker.io to collect other Docker images based on your requirements. Now, you are able to do that, but that wouldn't be my recommendation. My recommendation is to use the Azure Container Registry, which is similar to Docker Hub, but you're able to add a private endpoint. So you can have a private endpoint from your AKS environment, your virtual network subnet, and have a private endpoint to the container registry. And what you should do is probably pre-download all the Docker images you need and put them in that Azure Container Registry, and you can pull them in when you make deployments. Now, Kim, I know you have a lot of experience with networking, so I want to get your opinion on this.
So as far as that, the particular pattern you have here, so what we want people to understand is, so if you do set up this Azure Firewall to sort of, restrict your traffic. If it does restrict your traffic, you must have, so it's better to have something internal as far as your YAM goes, or however you have YAM or whatever you use as apt-get, whenever it goes out to the internet, whereas you don't restrict it too much, because when the gateway subnet is set up, it's allowing the traffic outbound to get to the internet at 443.80. So if you're starting to set up firewall policies on the firewall, you're going to start restricting more and more, and then you'll end up putting more and more policies as to what needs to get outbound and which domains. If you start restricting by domain, say, oh, I want to go to, just, the .io for anything for Docker, or if it's, whether it's google.com or whatever, then that restricts what's going outbound, right? Unless you have something to say on the firewall itself to have, okay, asterisk, everything can go outbound port 443 or port 80. But if you're just restricting, that's going to restrict everything. So you'll be ending up setting up separate policies to allow the traffic outbound and which subnet gets out. So you can set up that particular, a particular subnet or something to download those updates for you, and then you pull from that those servers, which would be better if you just had one server internally to pull all your downloads, and then you pull from that one.
Yeah, so you can do something like that. So say you want to pull containers, have your, like you said, have a separate VM, have that outbound access, pull that container in, and then load it into your container registry. And that's good for containers. Unfortunately, with AKS a little bit, they do require public access to some Microsoft domains. So that's why in this link, I have this link here that tells you the minimum required egress rules you need to put in the Azure Firewall.
Right. Yeah. So yeah, definitely that, on the egress. But like I said, those are the required outbound access for Kubernetes. Yeah.
Right.
But if there are other servers within that same subnet range or whatever that are trying to get out to the internet, whatever other servers you have, whether it be your custom VMs or so forth, they would have a hard time trying to get out. So if you're going to, pinpoint those particular subnets to say, okay, this one goes out, but it has to sit. The problem is it's sitting on the other side of your gateway subnet, right? Whereas you're saying, okay, any traffic that goes out to the internet goes out through this NAT gateway, but it's going to be halted here at the firewall. So if it's halted there at the firewall, that's where you're going to have to allow it to go on outbound.
Yeah, adding that Azure Firewall will affect the entire subnet. So you do have to make sure all your VMs have the required outbound access they need. One recommendation is to have just separate subnets, have a separate subnet for AKS and your custom VMs and separate that way. But that's up to the team manage the application. They can set up all they want. Yeah, so they can set up based on the requirements of what they need. But yes, if there's VMs and Kubernetes pods, containers in the same subnet, it will be attached to that firewall. All the rules will apply to that entire subnet. Now to talk a little more about role-based access and get away from the networking lingo a little bit. Azure Kubernetes allows two different ways to allow RBAC, role-based access control. There's Azure RBAC for Kubernetes authorization, which in this case, Azure creates this like pre-built roles that you can assign to users. And there is use Kubernetes RBAC with Azure AD integration, which is normal Kubernetes RBAC, but you're able to integrate it with your Active Directory and single sign-on logins. So the second option here that I mentioned is actually my preferred option because it lets you be more granular. Say I want to have a user in my company or team that just needs access to Kubernetes services, not the pod itself. They don't need to go into the application and look at logs or update any settings in your pod running your database or web server. So Kubernetes RBAC lets you do that. You can write a role that says, hey, I'm giving this member just access to Kubernetes services to deal with networking, and I'm only giving this person on my team access to exec in the pods because they don't need to mess with networking. All they need to do is go in the pod and make sure the application is running correctly or update config files. And that second option lets you do that versus the first one does not. But that all depends on your team's and application's requirements. So it's whatever works best for you. Both are just fine solutions from a security standpoint. Now you can also log into Kubernetes via Azure Active Directory single sign-on. For people with a lot of experience with Kubernetes, to log in, you get this kube config file. You put that locally on your server or PC or Mac computer, and you're able to run Kubernetes commands via the kubectl, kubeecho login. But the good thing about what Azure allows you to do is you can single sign on with Azure AD, so you can just use your Windows password. Less passwords, the better, in my opinion, because once a lot of users have different passwords, they write them in notebooks, they add them into just put in text files on the computer, and that's not a secure way to handle passwords. And Azure allows you to put conditional access policies on that too. So for anyone in your team to require access to Kubernetes, you can say, hey, you must enable MFA, and you can only get on if you have your correct MFA token. So in case if a kube config file is stolen and used, you should already have a private control plane, but say it's an internal threat, they have access to control plane, and they steal your kube config file, they still need your MFA token as well to access the cluster. So there's an extra layer of security, more of a defense in depth strategy. Conditional access policies also allow location-based access. So an admin of Azure can say, hey, I'm only going to allow access to this via if you're on our VPN or this private IP space. So altogether, you should have a private control plane, multi-factor authentication, single sign-on, and location-based or IP-based access. So having all those should keep your control plane of your cluster pretty secure. To make your access even more secure, like internally into the application, you should segment, have namespace segmentation. And for those who don't know, namespaces are like little sections that you can divide up in Kubernetes. And you can have one team use only namespace A and another team in your company only access namespace B. And they should not affect each other. Users should not have access to both, and the application running in separate namespaces should be completely isolated and should not have access to each other unless your application requires it.
So that's a good point, Chris, because when you're setting up those namespaces, if you're setting up your Kubernetes your Kubernetes environment, and you have, say, namespace bogus and namespace Pluto here, and the subnets that they reside in require them to have access to each other, then yes, of course, it would have to be required or be allowed. I'm sorry, but that's a good point. Yeah, but they should be segregated and not able to see each other or talk to each other.
And you can even take that a step further with internal Kubernetes network policies. I will warn you, they do get pretty complex. So definitely test ahead of time or have a test cluster to do this before you do production. But there are plenty of different solutions out there concerning ITSIO, Linkerd, HashiCorp Console. These are called service meshes, and you can add additional network policies on them. If you do play with that, don't do both at once. It will cause some trouble in your cluster. Don't have ITSIO and Linkerd. They will conflict. So we went over a few things about private access, and we talked about RBAC. So those are probably the minimum that you need to have a secure Kubernetes system. Some extra stuff you can look in for, add to it to enhance security of your cluster. Microsoft Defender has Microsoft Defender for Kubernetes, which essentially detects threats in your Kubernetes cluster. So say you're running a Windows pod in your Kubernetes system, and there's a PowerShell vulnerability or attack, Microsoft Defender will be able to pick that up. It'll also detect unusual connections to public IPs or malicious downloads into your containers. So that is an additional cost, and I don't like that because essentially what our CSO made an example of, you don't buy a car and buy the seatbelt later. It comes with the car, and I hope eventually all these cloud providers will build in these security features into their clusters, and instead of adding an extra cost, it's just built in. So I think that'll make a lot more people around the world more secure, because I know cost is a big factor for a lot of teams, and especially if you're just running a startup, you may cut security cost out of your application. But I don't recommend you do that. But I hope the cloud providers do make it a little easier and more accessible to add security without charging a ton of money. And one thing to also do is enable logging on your cluster. If you don't have logs, you can't find out what's happening. So enable audit logging, network flow logs if you can, and to make sure what you're logging doesn't contain any secrets. If you do have environment variables and you use secrets in environment variables, you shouldn't. You should mount them or have a different process to inject secrets in your application. But if you do use environment variables, these may be logged into whatever system you're logging into, whether it be the Azure Log Analytics or a storage account or your third-party system. So just notice that environment variables can be logged in plain text. So I don't recommend you use them as secrets. Now to talk a little bit about the container deployment itself. So say my website I'm building my website into a Docker container. I will launch it into Kubernetes and scale up to 100 pods or make it auto scaling. So if I get more traffic, it will scale up and down with the traffic. You should always scan your containers before you put them in the Kubernetes to make sure they don't have any vulnerabilities, and to patch and fix whatever you can. Your containers should not run as root. Some of these public open source containers do run the user as root, and you should try to avoid that as much as possible. You can enable privilege escalation on containers in Kubernetes. You should deny that, and you should definitely have some kind of system watching it to make sure your containers no one pushes containers that allow privilege escalation. Usage of the pod host path volume mounts should also be restricted to a known list. So only your monitoring pods. So for example, Prometheus, which is monitoring read writes of disks, that's an example that should be allowed to have access to the host path. Because the host path gives access to the underlying VM. So you have a container that isn't required to do that, an attacker or adversary could possibly compromise that container and use that host path to jump to other containers in your Kubernetes cluster. So you should definitely restrict access to host path for only required applications. And the same goes with immutable read-only file systems. Your container should only be able to read root file systems and not be able to write update. Because again, an adversary can potentially use that to affect other containers running in your Kubernetes cluster. And two final notes: never use the Kubernetes default namespace. Every Kubernetes cluster comes with a default namespace named default. You should never use it under any circumstances. Just create a new namespace and add stuff into it. And one recommendation is just to keep your application simple. A lot of security experts around the world the best thing you can do, even better than paying for, like say Microsoft Defender for Kubernetes, is or other threat detect or antivirus systems, is just to keep your application simple. Don't overdo it. Don't have any complex systems that's hard to track and hard to manage. And security by obscurity never really works out because there's always someone who's smart enough to figure it out. So keep your application simple so you're able to update and remediate any issues you see.
Yeah, keep it simple because complexity, you're going to always find those beings, people that always like to be complex in their organization. But yeah, keep it simple and you can't go wrong.